Welcome to Study Loop.
In this problem, we're given two insulating spheres, one with a positive charge and the other with a negative charge, that are both equal in magnitude and equal to 250 microcoulombs. And for the first part, we're given that a voltmeter is connected between points A and B, and we need to find the reading on the voltmeter. Now, the voltmeter gives the difference in potential, so the difference in potential of A minus the difference potential of B. Now, let's get started by calculating the potential at A. So the formula for potential V is equal to K, which is the Coulomb constant, times the charge Q, divided by the radius, which is the distance between the center of the point charge and the given point. So the potential at A is equal to the potential of the positive charge, so the potential of positive charge at A plus the potential of the negative charge at A. So that is equal to K times positive Q divided by, so the distance of A from the positive charge is actually 25 centimeters, because it's half the diameter. So we'll write 25 into 10 to the negative 2, which is the prefix centi, plus K times negative Q divided by, so the distance from, so this entire distance, so the center to center distance is 1 meters. This distance is 25 centimeters. So 25 centimeters. And this distance, so the distance between the surface and the center is also 25 centimeters. So we'll subtract 1 minus 25 into 10 to the negative 2 minus another 25 into 10 to the negative 2, and that gives us 1 minus 50 into 10 to the negative 2, and subtracting 50 into 10 to the negative 2 from 1 gives us 0.5. So the total potential at A is equal to KQ divided by 0.25, which is 25 into 10 to the negative 2, minus KQ divided by 0.5. We can factor out a KQ, and what we're left with is 1 over 4, which is equal to 0.5 minus 1/2, which is equal to 0.5, rather 1 over 1/4 minus 1 over 1/2. That gives us KQ times 4 minus 2. That gives us 2KQ as our potential at A. Now we'll do the same thing for B. So our potential at B will be equal to the potential of the positive charge at B plus the potential of the negative charge at B. Now we'll do the same thing. So the positive charge has a magnitude of, a charge of Q, and the distance it's separated by from the other sphere is 0.5. The negative charge has a charge of negative q that is separated by a distance of 0.25 meters, and what we're left with after its simplification is negative 2 kq. So our reading on the voltmeter is actually the potential at A, which is 2 kq, minus our potential at B, which is negative 2 times kq. That is just equal to 4 times kq. Now, k in SI units is equal to 9 into 10 to the 9th power, and our given charge is 250 microcoulombs, so that's 250 into 10 to the negative 6 coulombs, and what we get is 4 into 9 into 10 to the 9th multiplied by 250 into 10 to the negative 6, which is 9 into 10 to the 6th volts as the reading on the voltmeter. Now for the second part, we need to find which point A or B is at a higher potential, and how can we know this without any calculations. So we know that a positive charge generates a positive potential, and a negative charge generates a negative potential. So even without any calculations, we can conclude that the charge that is closer to the positive charge generates a positive potential, so A is positive, and the charge that is closer to the negative charge generates a negative potential, so B is negative. So A is the positive sub and E is negative, so A automatically has the higher potential, and that is our answer to the second part.